we're going to write a system of equations for these three problems. We're going to put it into Desmos, and we're going to find where our two equations, our two lines cross. These are all linear equations. So here we are. Michael is 4 times as old as Brandon. There's our first sentence, like part of the sentence that we can write an equation for. So Michael is 4 times as old as Brandon. I'm going to make Michael X and Brandon Y. Is always our equal sign. Michael is 4 times Brandon. Don't overthink it. It says, and also 27 years older than. So that's really, we could break this into 2 sentences and say Michael is 27 years older than Brandon. So if you don't have 2 sentences, I would almost write an extra sentence so that you have that Michael is, so you can do X equals. So X equals 27 years older. Well, Brandon's our Y. 27 years older, we're going to do 27 plus. It doesn't say times, so we're going to do plus. If we were doing younger, we would subtract. But we're doing older. And now we're going to put these 2 equations in to Desmos. All right. So our first equation was X equals 4y. Oops. And our second equation was X equals 27 plus y. I can only see one of these graphs right now, so I'm going to just zoom out until I can see both. That's it. Here we go. 36:9. So what I would write on my scrap paper, other than those equations, which I would definitely write, is just a reminder of what was what. Hey, my answer is 36:9. We made X Michael, and 9 was Brandon. And if we have one answer box for how old Michael is, we're going to put a 36 in it. Done. Our answer there is 36. Write the equations, put them into Desmos. You want where they cross. For this, if you're doing a system of equations, you are not interested in the y-intercepts unless the test is asking you to graph it. Okay? You're interested in where these 2 cross. Okay. Next problem. Dr. Potter provides vaccinations against polio and measles. Each polio vaccination consists of 4 doses. Each measles vaccination consists of 2. Last year, Dr. Potter gave a total of 60 vaccinations that consisted of 84 doses. Okay, so I see 2 categories here. I see like vaccinations, and I'm going to look at my totals for this, and I see doses.
This is a tricky one. It's hard to picture these things.
Yes. And that's why like using those words, labeling your equations is going to be helpful. So, the total numbers, remember we did something like this in this unit. We had something like that, where we had equation like x, y, total. X, y, total. Okay, so hopefully that'll be helpful. And now let's read again. So our numbers that go with, I see lots of dose numbers, so I'm going to go with doses. polio vaccinations consist of 4 doses. Okay, so I'm going to put that here. I'm going to make this polio. And I used 4, so I'm going to X it out. Measles vaccinations consist of 2 doses. So I use that. And the other number that goes with doses is 184. And that was our total. I'm crossing out the numbers that I'm using, so I'm not going to use them again. The only number I have left now is that 60. And that was the total. I don't have any other numbers. So what's that top line going to be? What do we do if we run out of numbers with the system of equations? Put in X and Y. And it should kind of make sense. If our vaccinations are made up of doses, it takes 4 shots to give one polio, to give one whole polio vaccination. It takes 2 shots to give one whole measles vaccination. But this one is, the wording on this one is tricky. I definitely agree with Mrs. Markgraf on that. All right, now put it into Desmos. See where your 2 lines cross. That's the work. The rest of it is Desmos and write down the answer. So the hard work on these is writing the equations. X plus Y equals 60. And then 4x plus 2y, was it 184? Riley? Thank you.
Thanks for following along. This is good practice.
So our ordered pair is 3228. If we go back to our little table that we drew, X is her polio. So our ordered pair was 3228. So that our X column is our polio vaccinations, and our Y column was measles. So we just have to make sure we match up. So 32 polio vaccinations and 28 measles vaccinations. Really start remembering how to make that grid and starting with those totals, I think, is the key to that problem. All right, last one. This is a different kind of systems of equations problem. So we've kind of had the 3 kinds that we saw. One where it was just kind of our age problems. This guy was definitely, we needed that table. This one is each sentence is going to give us an equation. This is kind of the don't overthink it problem. Each sentence is going to give us an equation. Eli brought 3 liters of milk and 5 loaves of bread for a total of $11. A month later, he bought 4 liters of milk and 4 loaves of bread for $10. So I'm going to make milk X, and I'm going to make bread Y, and I'm going to write my equations. 3 milk, 5 loaves of bread, $11. 4 milk, 4 bread, lots of toast that week, $10. Put it into Desmos. The other thing we've seen the OST do on these kind of problems is give you the system of equations and then ask you in detail about it. Either ask you to solve it by just putting it in Desmos, or maybe they give you specifics and say, the first equation is week 1, the second equation is week 2. How many loaves of bread did you buy in week 1? So you just have to find that 5. They would tell you that X is milk and Y is bread. These are definitely good problems to have the test read to you. because, again, hearing it and seeing it together is just going to let your brain process it a little better. Okay. 3x plus 4y 11. Ooh, 3x 5y. And double check your entry. And I'm going to go back to home here so I can see. Is that what you guys got? 75 cents and $1.75.
Yep.
The only other kind of problem that we've seen that you will definitely see today, and again on the practice and again on Monday, are sum and difference problems. Remember, sum, if you see a problem that says two numbers have a sum of and a difference of, sum is going to look like this. X plus y equals difference is going to look like this. X minus y equals. And you're going to treat it just like we treated those. So if you see a problem that really just says the sum of two numbers is 27. The difference of two numbers is 8. I don't know if that would work out or not. I'm just pulling numbers. What are the two numbers? Or what is the bigger of the two numbers? Write your equations, roll with Desmos.
Let's see one or two on Thursday next week.
Lovely. And they will see one on Monday in our review. All right. This is day 9.